Okay, let's dive into this. Welcome to the Explainer. Today, we're completely demystifying Linux administration for first-time users. We're drawing all of our insights right from a fantastic, hands-on beginner lab created by Tovar Tech. Look, if you've ever stared at a blinking cursor on a Linux terminal and felt totally overwhelmed, you are in exactly the right place. We're going to break down user accounts, groups, and the real meaning behind administrative superpowers into simple, bite-sized concepts.
Here is our step-by-step roadmap for today. First, discovering your Linux identity. Second, the user and group databases. Third, root, sudo, and superpowers. Fourth, managing users and groups. And finally, number 5, the final admin workflow.
All right, section 1, discovering your Linux identity. And hey, quick side note, if you get a permission denied error while learning, don't sweat it. It's not a failure. It just means the system security is working exactly the way it's supposed to. To get started safely, the Tovar Tech Lab recommends jumping into a disposable, browser-based environment. Specifically, we're talking about the JS Linux Fedora 33 RHCSA virtual machine. The beauty of this, it runs entirely in your web browser, so there is absolutely zero risk of breaking a real production server. Seriously, you can't accidentally delete the company database here. You can practice your commands, make mistakes, and if things go completely sideways, you just refresh the page. Bam, brand new, clean machine. So, picture this. You boot up this safe environment, and boom, you're faced with this daunting blank terminal screen. Well, the very first question you've got to ask yourself as a new admin is simply, who are you in Linux? I mean, how do you figure out your exact identity and what permissions you actually have? Now, what's really interesting is how just a few commands can instantly reveal your place within the whole Linux ecosystem. Try typing "who am I," and the system just spits out your effective username. Type ID, and you get the real underlying numbers, your user ID, your primary group ID, and any extra groups you belong to. Groups prints out that membership in a really clean text format, and log name tells you exactly how you initially logged in. In literally a few keystrokes, you go from being totally lost to knowing exactly who you are. Moving right along to section 2, the user and group databases. Let's see where this identity info actually lives behind the scenes. So, we know how to ask the system who we are, but where is it looking? Well, local user accounts are mapped out in a simple text file called /etc/password. Every single line represents a user, and all the fields are chopped up by colons. You've got the username, a password placeholder, the numeric UID and GID, a comment, the home directory, and the login shell. But here is a vital takeaway. Despite the name of the file, modern Linux systems do not actually store password hashes in this readable file anymore. It's really just for mapping identities. And on a very similar note, groups are defined in the etc/group file. Groups are a huge deal because they let you assign access to a bunch of users all at once, so you don't have to configure permissions for every single individual person. It's a huge time saver. This file is also colon-separated, showing the group name, a password placeholder, the GID, and then a simple comma-separated list of the members in that group. Okay, on to the fun stuff. Section 3. Root, sudo, and superpowers. This is where we shift from just reading things to actually taking action. And this brilliantly illustrates the core privilege model in Linux. On one hand, you have your regular user. They've got limited access, standard user IDs, and they mostly just stick to modifying their own files. But on the other side, you've got root. Root has a UID of 0, and that literally means ultimate, unrestricted power to change or delete anything on the entire system. Because root can accidentally destroy a system with just a single typo, real administrators usually avoid logging in directly as root at all cost. So instead of logging in as root, we use sudo. The lab gives this really fantastic, clear definition. Sudo basically means run this command with elevated privileges according to sudo policy. I really want to stress this. It's not a magic cheat code. For sudo to work, 2 things have to happen. The sudo software obviously has to be installed, and your specific user account must be explicitly allowed to use it by the system's policy. That policy, it's controlled by a file called sudoers, and wow, is it sensitive. As the source material warns, a syntax error in sudoers can lock administrators out of sudo. This highlights just how insanely dangerous it is to casually edit the main sudo policy file with a normal text editor. Administrators always use a special command called thissudo. Thissudo safely opens the file, but more importantly, it checks your syntax before saving.
That way, you don't accidentally lock yourself out of your own server because nobody wants to deal with that mess on a Friday afternoon. All right, let's step it up a notch. Section 4, managing users and groups. Time to use those superpowers.
Here is your daily toolkit for managing user and group life cycles. With your new admin privileges, you can fire off a user ad to spin up a new test user. Just toss in a -m if you need to generate a home directory for them. Then, use password to set their password. When they don't need access anymore, boom, userdel gets rid of them. The exact same logic works for groups. Group add creates a new group, and groupdel wipes it out cleanly. These are absolutely your bread and butter commands. So the crucial point here is a stark warning about a seemingly tiny typo. When you assign a user to a supplementary group using the usermod command, you must use the -ag flags. That A stands for append. If you forget it and just use -g, the system will literally replace all of the user's existing supplementary groups with the new one. That one little slip-up can accidentally overwrite and delete a user's critical access to other projects. Which brings us to our final stretch, Section 5, the final admin workflow. Let's put this all together. This is where all those puzzle pieces finally snap together into one cohesive scenario. The lab walks us through building a practical mini admin workflow in 4 easy steps. Step 1, you create an app team group. Step 2, you create a test user and safely append them to that group using usermod ag. Step 3, you create a shared project directory, drop a notes file in there, and lock it down. And step 4, because every good admin cleans up their messes, you run the cleanup commands so you leave the system exactly as you found it. Let's move to step 3 and see how this builds into real security for our shared folder. To make sure only our designated team has access, we first use chgrp-r to change the directory's group ownership to our new app team. Then we get specific with our group-focused permissions. Running chmod 770 on the directory means the owner and the group get full read, write, and execute access, while everyone else gets absolute 0. Running chmod 660 on the file itself means the owner and group can safely read and write to it. And just like that, we're at the end of our explainer. But the Tovar Tech Lab leaves us with a really brilliant challenge. Before you ever touch a production Linux server, ask yourself, can you confidently explain what a UID, a GID, and sudo are in your own words? I completely encourage you to go spin up a safe disposable VM. Run through these commands, make some messy mistakes, and practice until it's all second nature. Master these basics, and for sure, you'll be well on your way to becoming a confident Linux administrator. See you next time.